everybody, I am Hiba Izzat. In this video I am going to show you how can we calculate the centrality measures and the variation measures using Excel. So if we have a variable for the salary, for example, and we want to calculate the mean or to find the measures of the centrality of this data set. So to calculate the mean, we need to find the total of the sum of total of these numbers equals, we'll go here and to find the sum and it automatically will select the range of our data. We just click enter. It gives us the total amount of the total salary of all of the observations. To find the mean, we just need to divide this value by the number of observations. We have here 5 employees, so we'll divide this by 5. Also, if we want to find the median, we have to, I will take this column in another place and I will copy this column and paste it. So to find the median, I need to sort these numbers from the lowest or the smallest to the largest. So I will go to the sort and the filter, and I will sort from smallest to largest. So here the median would be the midpoint that divides the data set into 50% lower than this point and 50% upper than this point. So in this case, the median will equal to 1,500. Of course, this can be done with much easier steps than doing these 2 steps manually. I will just take this column again, copy and paste it here. Okay, just leave space. So I'm first going to calculate the mean, the median, and the mod. Of course, here the mod equals to 0 as no data observation is repeated. To take the same format, I'll take the format brush and put here. So to calculate the mean, I don't have to go to the steps of finding the total, then divide the number by the number of observations and so on. All what I have to do is write equal average. I'll open bracket and select the set of my data and close the bracket. That's it. Very simple. It's already calculated. So here we find that the mean can be calculated by just writing equal average, and it will insert and I will select the whole set inside the brackets and it will get me the mean. Again, For finding the median, I don't have to sort the data and find the middle point and so on. I just will write equal median, and it appears here, and I will select again my data set and click enter. I find the results resemble my results, that very easy using the functions inside Excel. And it's NA again because there is no repetition and no observation have been occurring so many times. So very easy using the Excel to find the mean, the median, and the mode. This is for the centrality measures. For the variation, this is the table we have filled in the previous video. The example is that the company has selected some of its employees as a sample, and it collected data about their salary and the years of experience in order to study the relationship between is the salary paid to their employees depend on the number of years of experience or not. So again, to calculate this or to answer this question, this could be answered using the finding the covariance and the correlation. The main problem with the covariance is it's really hard to interpret its results. So the correlation is usually it gives us a number between -1 and 1. If it's 0 or near to 0, in this case there is no correlation at all. If it's between 0 and -0.5, in this case there is a negative correlation, but it's weak. The relationship is weak. If it's greater than 0.5 to, of course, it gets stronger as it approaches to -1. In this case, it's a strong negative correlation or relationship between the two variables. If the correlation value is between 0 and less than 0.5, in this case there is a positive correlation, but it's weak. If it's greater than 0.5 till reaching +1, in this case the correlation is stronger, and there is a positive correlation. Of course, by positive correlation we mean that when one of the variables increase, the other will increase, and in the negative correlation, if one of the variables increase, the second will decrease. So to calculate this, we had to find the difference between the values here. Okay, the difference between each variable, the x observation xi, toward their means, and we find the subtracted value here. We should subtract 1000 from the mean. No, there is some problem. I think the data, it's 1015 and so on, so here it should be the first observation gets the 1000, and I will erase the, or I will leave it again. Insert down. These values refer to the total and the mean. So here we have to find the difference between the first observations and the means. I will fill it with gray, and I have to find also the difference between the individual observations of the second variable and its mean. This is to get the covariance, which is the summation of these two differences multiplied together divided by n minus 1. In this case we have n 5 observations, so n minus 1 is 4. So we get here the value of the covariance by here the multiplication of these two columns together. We multiply each value with each respective value. After multiplying these two values together, I find the summation of these values, and then this summation should be divided by 4, which is n negative 1. This would give us the covariance. It's really hard to interpret this value. So in order to calculate the correlation, we have to find the square of the difference between the observations and their means for the x values. I'll fill this with the orange and find again the square of the difference between the individual observations and their mean for the second variable, which is the number of years of experience. Then we find the total of these two values. We multiply to find the correlation. We multiply the summation of the two differences and divide it by the square root of the summation of the squared difference for the x's and the square root of the summation for the squared differences of the y's. Then we get the correlation. It's much easier to interpret in this case. It's negative and it's not close to 0, so there is a relationship between the salary and the years of experience. Due to the negative sign, we say that the relationship is negative, or it's an opposite relationship. So when the years of experience or the salary is not related directly to the number of years of experience, so it doesn't imply the increase in the years of experience would increase the salary, and it's weak because it's less than negative 0.5. So again, to find this using Excel without going in much detail or calculating all these values by hand, all what we have to do for, if we want the variance, to calculate the variance and the standard deviation. So This is started with the ex-employee. I write here equal variance. It will appear here. We'll select var.s. var.p refers to the population, and of course we are considering a sample, not a population. So I will select the function var.s and simply again select the range of our data, close the bracket and press enter. You can notice that this value equals the value we have calculated, but after following these steps. For the standard deviation, I can do it by two ways. Either I can find the square root sqrt function of this value, you can see again it resembles the one we have calculated, or I can again write dev refers to standard deviation dot s, standard deviation for the sample. Select the range of my data. This would benefit me if I haven't calculated the variance, so I can calculate the standard deviation directly. To calculate the covariance, I can type the equal sign cov. We find here again covariance.s, and I will calculate, or I will select the range of the x's. Of course, it's very important that covariance is calculated to find the relationship between two variables. So you'll find here it's called array 1, refers to the set of the data included in the first array or the x's, and here array 2 to select the range of the second data. Then close the bracket. Again the same of our value. Then for the correlation, I will write equal cor. I find here correlation, and again array 1 and array 2 to select the first set, the first data, and the second, the data for the second variable. Then I'll close the brackets. Here again we find the correlation of our sample. So Excel made it very easy for us to calculate them, and if we want to calculate them manually, we have to find at the beginning the difference between the observation and the mean for the two variables, and find the squared difference, and just we have to find the total of these values and substitute in the formula for the covariance and for the correlation in order to find their respective values. I hope it was very interesting for you, and thank you for watching this video.